Okay guys, I only have about a couple minutes to get through this real fast. This was the most missed question, the most asked about, so I want to just go through this quickly. Notice this problem says f of x equal x ln x. The minimum value attained is what? Because it's asking for the minimum, it's talking about an absolute minimum. So I'm trying to figure out what the y value is at that minimum point. Well, minimum values can only occur at endpoints or at critical numbers. This doesn't really have endpoints because this is going to go from, well, the domain is restricted. We can't plug anything negative into natural log. So it has to happen sometime between x equals 0 and x equals infinity. But we don't really have clear endpoints. So we're going to start by just looking for our critical numbers. And the way we find critical numbers is setting the derivative equal to 0. If this is free response, you'd probably get 1 point just for writing that. So make sure you're always writing that down. Well, if I'm going to find the derivative, it's going to be first times the derivative of second plus the second times the derivative of the first. If I simplify that, this is going to become a 1 plus an ln of x. Well, I want to figure out where that equals to 0, so I'm going to subtract 1 on both sides, and then I'm going to do an e to the on both sides, which is going to give me x equals e to the negative 1. Or in other words, I have x equals 1 over e. Well, I need to make sure we actually have a minimum value, because notice one of the options is that there isn't a minimum. So I'm going to make a number line. I'm going to put 1 over e on it. This is really only going to go to a value of 0 because the domain for ln of x is restricted, but it could go all the way to infinity. So I'm going to test this interval. I'm going to test this interval. We're going to start with f prime, which will give us information about the slope. So something bigger than this is 1 over 2.7 roughly. So if I plug in something like e is a value that's bigger. So I'm going to plug in e into my derivative. Remember, this thing here is my derivative. So I'm going to have 1 plus ln of e. ln of e has a value of 1, so this is going to give me a positive slope. Back here, the only thing I can really think of quickly that might plug in nicely is something like 1 over e squared. That's the same thing as e to the negative 2. If I want to evaluate here, I'm going to have 1 plus ln of 1 over e squared. That's the same thing as 1 plus ln of e to the negative 2. Well, ln of e is going to, those are inverse operations, so I really have 1 minus 2. That's going to be a negative value. So if my slopes are positive and negative, that tells me my original function is decreasing and then increasing. So this actually is going to be a minimum. But notice it's asking for the minimum value, not where it's occurring. So I'm going to have to figure out what the minimum value is by plugging 1 over e into f. So it's going to be 1 over e times ln of 1 over e. We just did this a second ago. This is the same thing as 1 over e times ln of e to the negative 1. It's the same thing as 1 over e times, these are going to undo each other. I'm left with negative 1, which is a negative 1 over e. So the correct answer was A. Okay.